Here are the solutions to this week's problem set. According to Gallup, 45% of Americans actively seek out organic foods when shopping. Suppose a random sample of 500 Americans is selected and the proportion who actively seek out organic foods is recorded. What value should we expect for the sample proportion? Well, there's no reason to expect that our sample is very different from the population, so we would expect that our sample proportion also is about 45% or 0.45. B. Show that this sample is large enough to apply the central limit theorem. So we have to show that n times p and n times 1 minus p are both greater than 10. So our sample size was 500, and p, the population proportion, is 0.45. So we have to show the reader that we checked that 500 times 0.545 and 500 times 0.55, note this is 1 minus 0.45, that these values are both greater than 10. And so what's important about that is that we can now apply the central limit theorem. Now what the central limit theorem says is that sample proportions will vary from sample to sample. Some might be 45%, some might be 47%, some might be 43%. But the shape of the sampling distribution of the sample proportions will be normal. The center will be the same as the population proportion, which is 0.45, and the spread, the standard deviation of this distribution, which remember is called the standard error, is given to us by the formula. Let me jot it down over here. The standard error formula is the square root of p times 1 minus p divided by n. So the standard error for this distribution would be the square root of 0.45 times 0.55 divided by 500. And let me just grab my calculator and work that out for us. So if we do that calculation, we'll get 0.45 times 0.55 divided by 500, and we're taking the square root. We're going to get about 0.02. And you can round it off to 2 or 3 decimal places. I'm just using 2. All right, so we found the sample proportion, our expected value for that. We showed that the sample was large enough. We just found the standard error. Part D. Using your answers to Part B and C, complete this sentence. In a random sample of 500 Americans, it would be surprising if blank percent actively seek out organic foods while shopping. Well, remember that whenever we have a normal distribution, it's surprising if you're more than 2 standard errors from your mean. So this area here would be surprisingly low, and then there would be a matching one on the other side that would be surprisingly high. So this number here would be 0.45 minus 2 standard errors, or in other words, 0.41. So it would be surprising if less than 41% actively seek out organic foods when shopping. Complete the sentence again, but this time use a number, not a percent. In a random sample of 500 Americans, it would be surprising if less than blank people. So now instead of a percent, we want a number of people. So 41% would be surprising. 41% of 500 would be, and if we just do that calculation, that would be 205 people. So it would be surprising if fewer than 205 people actively sought out organic foods. Use your sampling distribution to find the probability that more than 50% of the sample actively seek out organic foods when shopping. So again, our picture looks like this. We have a normal distribution. We know the center is at 0.45. We know the spread, the standard error is 0.02. And we were just asked to find the area here that is greater than 0.50. And we're going to do that using a normal calculator. So just like we did in Chapter 6, we're going to go to StatCrunch. We're going to pull up our normal calculator. The mean is 0.45. The spread is 0.02. And we want to find the area that's greater than 0.50. So let's go ahead and do that. So again, we're going to pull up our normal calculator. So stat calculator, we want our normal calculator. We have a distribution whose mean is 0.45 and whose spread, whose standard deviation is 0.02. And we want the probability that we are greater than, so we're going to change this to a greater than sign, and we want greater than 0.50. And so our answer is going to be 0.006. So you can see it's shaded here to the right, a very small region, 0.006. So let's go ahead and record that. This area is equal to 0.006 or 0.6%. So that's an example of a central limit theorem problem for sample proportions. All right, let's try problem 2. Gallup took a random sample of 1,022 American adults in 2017 and asked them if they trusted the executive branch of government. Of those sampled, 460 said yes. Construct a 95% confidence interval for the proportion of all Americans who trust the executive branch of government. Okay, so our sample proportion is 460 out of 1,022, and I'm just going to change that into a decimal for us. So our sample proportion is 45%. And so the question is, based on that sample proportion of 45%, what does it tell us about the entire country, all American adults? So we don't do confidence intervals by hand, but I'm just going to draw a picture for you of what StatCrunch is going to do, just to review how we do confidence intervals and the theory behind them. Let's make sure that the central limit theorem can be applied. So let's make sure our sample size was sufficiently large. So n times p in this problem would be 1,022. And we're going to use our sample proportion because that's all we have. We don't have a population proportion. And so I can check either with a calculator or with my good number sense that these values are both bigger than 10, and that means that I can apply the central limit theorem. Now remember, what the central limit theorem says is that the sample proportions will vary from sample to sample, but their shape is going to be like this. The center would be at the population proportion. I don't know what the population proportion is, but I know that my sample proportion is the best estimate I have. I could then compute the standard error using the formula we used in the previous example, and then I know that if I go out roughly 2 standard deviations on each side, about 95% of my samples should be in that region. So that's the theory behind a 95% confidence interval, but in practice what we do is we let technology do this for us. So we're not going to bother to compute this number, we're not going to bother to add and subtract, because our computations are at best going to be estimates. So instead we're going to use technology, which is going to be much more accurate. All right, so we're going to go to StatCrunch. And we're going to go to Stat, Proportion Stats. We have one sample, and we have a summary. So the number of successes was 460 out of a total number of 1,022. Now, we have to remember to click the box that says we'd like a confidence interval. And so make sure you click your confidence interval box. Make sure the level is the level that you want. I do want a 95% interval, and so we'll now compute. So we have a lower limit of 0.42 and an upper limit of 0.48. So let's write that down. So our confidence interval is going to be 0.42 to 0.48. So we usually write an interval like this, as you've seen in the notes before. So there's our 95% confidence interval. What is the margin of error for your confidence interval? So remember, the margin of error is the distance from the center to one of the limits. So that is the margin of error. And the easiest way to do that, to find it, is to simply subtract these two numbers. So if you subtract 0.48 minus 0.45, we get a margin of error of 0.03. So this is our margin of error. The most common mistake is to subtract the upper and lower limit. If you subtract the upper and lower limits, you get 2 margin of errors, so be careful about that. Okay. If an article used the headline, "More than half of Americans trust the executive branch," would you believe this based on your confidence interval? Why or why not? Well, remember, more than half would be 50%. So 50% would be right here. Now, where's our interval? Our interval goes from 42% to 48%. Notice that our interval is below 50%. So is 50% a believable value for the population proportion? No. And so would I believe this headline? No. Why? Because our confidence interval is below 50%. The only kind of interval that would allow us to believe that headline would be an interval that was completely above, this is wrong. I put it in the wrong spot. Completely above 50%. If the interval was over here, above 50%, then I would believe the majority felt this way. But given the interval that we got, we don't believe that that's true.